Hi everyone, I'm Ruchi and today I'm here to speak about Apache Kafka plus MQTT, a Powerpack combination for end-to-end testing. Um, so let's start with the introduction to Apache Kafka and understanding the core concepts and architecture. So first of all, how many of you are familiar with Apache Kafka? Okay, so for those who are not familiar, let me introduce. So Apache Kafka is basically an open source event streaming platform used to collect, process, store, and integrate data at scale. It has numerous use cases, including distributed logging, stream processing, data integration, pub/sub messaging, and like many of the others. So in order to make complete sense of what Kafka does, we will delve into what an event streaming platform is. So event streaming platform is basically, like Apache is an event streaming platform and it streams events, like it uses topics to, like use that events and yeah. And it is divided into key value pairs, sort of. So yeah. So before delving into Kafka architecture or its core components, let's discuss what an event is. So basically an event is any type of action, incident, or change that's identified or recorded by software or applications. Example, uh, like in this case, I'm sharing a PPT, so it's an event, right? A website click, you click a website, you do the payments, it's an event. So yeah, that's a basic example of what an event is. Uh, so let's delve into the architecture of Kafka. So like in Kafka, Kafka cluster is basically the server which acts as a container, and it has like more than one broker, like, one, two, three brokers. Like the more number of brokers generally determines the, like your application is reliable, scalable, and reliable to fail over. So yep. So in this case, what a producer does is producer pushes a message to the Kafka brokers, and yep, like Kafka brokers are dependent on Zookeeper. They are like basically managed by Zookeeper. So Zookeeper is like the broker leader in this case, which manages all the brokers and it handles all the events that are going on. So Zookeeper is basically the broker leader in this case, and producer pushes messages to the Kafka brokers, and like this messages gets a Kafka broker ID via Zookeeper, and like consumers consume that messages or pulls that messages from the like the from the producer, and Zookeeper updates the offset into it. So this is a very high level overview of Kafka and its architecture. So yeah, like let me also go through the Kafka broker, Kafka Zookeeper, and all. So Kafka broker, to maintain the load balance, Kafka cluster typically consists of multiple brokers. As I said, the more number of brokers determines the your application is more scalable, reliable, and reliable to failovers. So and these brokers are stateless. So, like for maintaining the clustered state, as I said, brokers uses Zookeeper. So, although one Kafka broker instance can handle hundreds of thousands of reads and writes per second without the performance impact, each broker can handle terabyte of messages, like hundreds of messages and like many more. So, one broker is also sufficient, but it's like recommended to have more of them. So, yeah, like. Uh, let's see what Kafka Zookeeper is. Kafka broker uses the Zookeeper, so it is dependent on the Zookeeper. It notifies producer and consumer about the presence of any broker in the Kafka system or failure of the broker in the Kafka system. So as soon as Zookeeper sends the notification regarding the presence of failure of the broker, then producer and consumer takes the decision and starts coordinating their task with some other broker. Uh, so Kafka producers are, client applications that publish rights events to Kafka. Producers in Kafka push data to the brokers, as we saw. So also all the producers search it and automatically sends a message to that new broker exactly when the new broker starts, so however, we need to keep in mind that the Kafka producer sends messages as fast as the broker can handle. It doesn't wait for acknowledgements from the broker. And Kafka consumer, on the other hand, subscribes to the topics and consumes the messages from the producer. It pulls messages from assigned partitions. Kafka consumer maintains that how many messages have been consumed because Kafka brokers are stateless, right? So moreover, you can assure that the consumer has consumed all prior messages once the consumer acknowledges a particular message offset. So yeah, and the next is Kafka topic. So Kafka topic is basically a logical channel to which producers publish message and from which the consumers receive message, right? So a topic defines the stream of a particular type classification of data in Kafka. So these messages are structured or organized, and a particular type of messages is published on a particular topic, and this topic is identified by its name, and it must be unique. So there can be any number of topics, and there is no limitations. So the next is introduction to MQTT. So MQTT is a messaging protocol based on certain standards. Like it acts, depends on the certain standards or set of rules used for machine-to-machine communication. So smart sensors, wearables, and other Internet of Things like IoT devices typically have to transmit and receive data over a resource-constrained network with limited bandwidth. So MQTT has become a standard for IoT data transmission due to certain benefits like it's secure, it's lightweight and efficient, and scalable. So like you might be thinking that how does MQTT work actually, right? So an MQTT client establishes a connection with the MQTT broker first, and once it is connected, the client can either publish messages, subscribe to specific messages, or it can do both. So when the MQTT broker receives a message, it forwards it to subscribers who are interested to consume it, right? So let's understand the MQTT publish subscribe. So MQTT topic, the topic refers to keywords, and the MQTT broker uses to filter messages for the MQTT clients. MQTT publish is like basically MQTT clients publish messages that contain the topic and data in byte format. So client determines the data format such as text data, binary data, XML, or JSON files, right? And MQTT subscribe is MQTT clients sends a subscribe message to the MQTT broker to receive messages on topics of their interest. And this message contains a unique identifier and a list of subscriptions, right? So next is what's quality of service labels in MQTT. So MQTT supports the three different quality of service labels. First is at most once, or also known as fire and forget. So the message is sent to the recipient without any confirmation, and like the recipient or the sender whom the message is to be sent does not wait for acknowledgement from the receiver, right? So the message is delivered at most once, and there is no guarantee of delivery. So the next, here comes the next level, which is at least once, and also known as the acknowledged delivery. So the message is delivered at least once, ensuring that it is not lost, but duplicates may occur in case of network issues. And in this case, when the message is sent to the recipient, it waits until that, like sender receives it, or, forwards some acknowledgement of the sent message. The next quality of service level is exactly once, or the assured delivery in this case. So the most reliable level, ensuring that a message is delivered exactly once. So this is like an optimal version of all the levels previously, and it involves like a two-step handshake process, which is the sender sends a publish message, the receiver acknowledges the receipt with a pubrec sort of command, and the sender acknowledges the acknowledgement with a pubrel. So the receiver then confirms the final delivery of a message with a pubcom, which is acts as a certain kind of acknowledgement. Right, so this level provides the highest assurance of the message delivery and eliminates duplicates, and most of the applications, assure that this level is present in their application. So let's see the integration of MQTT and Kafka now. So integrating Kafka and MQTT can be beneficial in various use cases, leveraging the strengths of both technologies to create a robust and scalable system for handling real-time data and messaging. So MQTT is mainly used in Internet of Things scenarios like connected cars or smart home, but it is also used more and more in mobile devices due to its support for WebSockets, right? So let's see some common use case. The end-to-end IoT integration using MQTT and Kafka. So in this example, you pull the data from the MQTT broker via Kafka Connect method to the Kafka broker. Then you can leverage any features of Kafka Connect, such as built-in fault tolerance, load balancing, converters, single message transformers for routing and filtering, etc., or scaling different connectors in one connect worker instance and other connect-related benefits. Right, so like the device sends, like the MQTT device sends the message to the MQTT broker. The MQTT broker receives it, and via Kafka Connect method, it sends to the Kafka broker, and Kafka broker then sends the message to the Kafka consumer for the delivery of the message, right? So let's see one more use case, which is Glee, which is a project of async API. So let's see how Glee leverages Kafka and MQTT, right? So Glee is a spec-first framework that helps you build server-side applications. It supports all protocols like MQTT, Kafka, AMQP, WebSockets, which act as an adapter, and supports message logging and other functionalities that this adapter provides. So let me show you the Glee project. So this is the Glee project, which I am talking about, and this is the Kafka adapter, implementation of the Kafka adapter. So in this, we have we have Kafka adapter, which we have a Kafka adapter, which which has a Kafka instance and which sends messages to the Kafka brokers, and there is also the producers and consumers. So Kafka adapter sends a message to the Kafka broker. Kafka broker acknowledges it and sends a message to the Glee, which is known as the Glee message, which is this via the async send method. So Glee sends a message, Glee acknowledges the message and it sends to the consumer, and yeah, it creates a message and it sends to it. So this is like a basic overview of the Kafka adapter in the Glee, and this is the Glee project that I'm talking about in the async API. So yeah, it's a kind of intermediate project, but yeah, it can give you a good hands-on on Kafka and MQTT, and it has all the adapters, and it supports all the protocols basically, like MQTT, AMQP. So in the adapters, in the source adapter folder, you can check we have HTTP, Kafka, MQTT, WebSockets. So we have all these protocols. So yep, that's about it mostly. So yep, if you have any questions, answer them.
Questions? I feel like I've been singing this song today. Does anybody have any questions when it comes to Kafka and MQTT? Okay.
Can you talk a little bit about the Glee framework, what you're talking about? I did not quite get that.
Sorry, what? Talk
About Glee?
Yeah, sure. We can talk more about Glee. So what do you want to know more about? So Glee is basically, right now, we are releasing the version 3 of the Glee, and there are many, ongoing stuff that's going around with Glee. So, Glee, a quick overview of what Glee is basically. Glee helps you to build server-side applications. Right. So, for example, you can use the just a Glee async API Glee command, and it would, install all the libraries, dependencies, all that you need for your particular business case, and it does all that for you. Example, if you install Node.js, or what you do, you go to command line, you type the Node.js command, and it installs the Node.js library, and it you have to do all that manual job, right? But in case of Glee CLI, Like the async API CLI, you have to first install the async API CLI, and via the command like async API CLI glee command.
API first, I guess that's what you're mentioning, right?
Yeah.
So how does that work out? I was just curious. That was my question. Sorry, it was not clear earlier.
Yeah, so like like Glee like helps you to write the APIs, and like like with Glee you just have to write your business case, the code for your business case. It does all the documentation and stuff. But yeah, like it's a spec first, and you have to like like you have to customize the like what you need exactly to Glee. So Glee is basically gives you an interface to code for your business case, but it doesn't give like a ready-made API or a sort of kind of stuff that you can use it. So I hope you get my point, or I'm clear. Yeah, thank you. So
Quick question. You talked about the quality of service, QoS 1, 2, 3. These are all MQTT specific. Does it transcend the Kafka broker, or it's only for the MQTT?
it's only for MQTT.
Anybody else with a question? Okay, thank you so much, Ruchi.